So we are in live now, sir.
Mm-hmm.
Sir, can you switch on your video, sir, so that participants can see you, and later you can start the session. Yes,
Okay.
sir. So, very good morning to all the participants, and it is a great pleasure to have you all here for day 4 session of School Teacher Capacity Building Program on Artificial Intelligence, which is a unique initiative taken by our beloved chairman, Sri P. Sriram, a successful first generation entrepreneur, a well known industrialist, and managing director of MK Group of Companies. And today's session is going to be definitely interesting, like data modeling. So now we are happy to welcome our guest speaker, Dr. Anurag Nagar, is a faculty member of the Computer Science Department at University of Texas, Dallas. He teaches advanced level courses in machine learning and big data technologies. He has industry experience as well and has conducted many workshops for corporate and academic audiences. Now I hand over the session to Dr. Anurag Nagar. Sir?
Okay. Thank you, Dr. Dhanlakshmi, and it's great to be with you guys. I wish that I could see you. I don't know if you guys can see me, but I'm sure you can hear me. So, good morning, everybody. How are you? Okay. Maybe I wanted some feedback, but that's okay. I guess you guys can hear me. Okay.
Yes, sir. So they can hear you. Yes.
Okay. So I hear
You can
some.
just go ahead, sir.
Okay, so what we'll talk about today is data modeling, especially as applied to AI and machine learning. So basically, the aim of data modeling is you are given a function and you are given a data set X and you are given an outcome Y. For example, the data set could contain the features of every house, and the outcome that we want to predict could be the price of a house. So you want to create a data model that takes in the features of the house and predicts to me the price of the house. Similarly, there can be multiple examples is you take the number of hours that a person has studied and you use that to create a model that will predict the percentage of the score that he will get in the exam. So it is using a set of attributes that we call to predict an outcome variable. So you can if I could write on the board, then I would say there is an f function. F function takes attributes and predicts the outcome. The outcome could be a single outcome like price of a house, or the outcome could be a set of values. For example, the GPA of the person and the grade that they got, or something other. So what we need to do is we need to figure out this function, this correlation between X and Y. Now, before we do data modeling, we have to have some background, like what do we need before we start data modeling. So machine learning or data modeling is something that steps between you and the task that needs to be done. So for example, we have written code in the past, and what did we do when we wrote code? We said, okay, what happens if the user enters this value? How would our system respond? Well, I have to program it, right? So if I say if the user clicks a mouse here, then how would my program behave? So I will give it maybe some instructions, if then loop. So if the user clicks their mouse at position X or on button X, then this is how my system should respond. This is how it should work. So think of the middle part is you thinking of every situation and programming the computer. Now, what happens in the new system or new model is we could, instead of you having to tell the machine what to uh, like you having to program the machine can learn by itself from the data. So that's where we are headed to, stopping the human intervention and making the machine so that it can learn from the data and learn to create a model from the data itself. So machine learning is a method of data analysis that automates model building. So the process of model building, when it is automated, that is called machine learning. So what I mean by that is machine will take in as the training data and it will learn to predict the outcome. And there are many situations you can see that where that happens in daily life. So what happens is we design algorithms that learn iteratively from data. So the machine starts with small amount of data, it does the prediction or data modeling. Then, if you give it more data, it does a better job. It improves upon itself. And let's see where we are using that approach of data modeling is all of you have interacted with recommender systems in some capacity or the other. For example, you might watch Netflix, and in Netflix, it gives you recommendations. You might order stuff on Amazon, and Amazon gives you some suggestions that you might also be interested in this. And there are other things, you can think about your daily life is you wherever you go, like Facebook gives you friend suggestions. So all that is an example of the machine creating a model from what? From your history and learning to predict your future move, like what could you be interested in. So that is the model building process. So for a model building process, you need at least two things, which is you need the training input data and you need the training output data. And we are going to create a mathematical model between the training X, which is input, and Y, which is the output. So I don't know if you have any questions, then you can maybe type it in the chat thing, and just wanted to make it interactive. Okay, I see some questions. Okay. Okay, Sugit Sethi, he's typing something. How machine learning is different from traditional learning? Well, for one, obvious answer is you have a machine stepping in for the human. So there may be some tasks that are very much so that you can program a machine to do that. For example, there are many tasks in our daily life where instead of us learning to program, or if instead of us doing the same thing again and again, we can let the machine do its job. And so the machine, okay, so okay, I see something in chat. So if you if you have questions, please ask. So Premlata, they're sending some private messages. Uh, so anyway, if you have questions, please ask. It's nice to get feedback from the listeners and participants. Varalakshmi, for school student, is it easy to learn machine learning? Uh, yeah, I would say yes, because these days, the students. Do we need to code machine for learning? Anand is saying that's good question. Varalakshmi is saying for school student, is it easy to learn machine learning? So let me answer Varalakshmi's question first. Is yes, these days the model is that we can train a machine with very minimal amount of code. So earlier model was you have to write a lot of code to make the machine learn. The new model is that we can make the machine learn with very limited amount of coding. And if we had more resources, I would probably show you an example is where our students learn to design a machine without writing any code. So it's a visual approach. Uh, Okay, so it's a visual approach in which we can train the machine without writing any code. So such things are available. So you're asking for school students. Yes, of course, we can tell machine learning or we can reach out to students in the school level so that they can program the machines without having to know much coding. Okay, so this is the machine learning algorithm, machine learning thing. And what happens is that it takes an input and predicts output. So it's very easy to determine what is the input here. Input is my previous history. And the output is what am I trying to predict. So in that case, it's pretty easy. Another example that we talk about a lot is training a machine to classify email as spam or no spam. It's a classic example, it's been given for a long time. People have given this example is I train a machine based on the features of the uh, email to predict it as one means spam, zero means no spam. And that is one of the other examples. The next example could be facial identification, which is I look at the images or the features of an image and I learn to identify a person. That's another hot area, which is facial detection. And for any machine learning or data modeling application, I would request, first of all, to realize what is the input data or what is the training input and what is the training output. So, for example, if I wanted a machine to predict the attendance of students, then what would be my input data or input training data? Well, you can say I want to, my output is whether the student arrives to class on time or late. So it's a Boolean. Let's make it very simple. A Boolean. One meaning student arrives on time, zero means they arrive late. And what is the background that you need to know to predict that? So maybe we can monitor the rainfall. If it is rainy, then the person is more likely to be late. We can also monitor like traffic conditions, etc., etc. So we can say you have to identify before data modeling what is you are trying to predict and using what. So those are some of the fundamental questions. So now for data modeling or machine learning, okay. Another good question by Premavati. Is it possible for a class 6 or student to learn machine languages? Um, First of all, what is a machine language are you talking about? Are you talking about machine learning technology or machine language? I didn't really understand what is machine language, but I think you mean machine learning programming. Uh, Yeah, there are many software for that. I could send you. So there is a software developed by Google called Google Colab and Visual TensorFlow. So for sharing with your students, there is a something called TensorFlow Playground, which is I'm going to type it in the chat box. This is one of the tools released by Google to do visual training of a machine. So it's a very simple thing. I mean, right now it's very simple that you um, take the input and the machine will visually train for you. It will train, how it wants to learn without writing any code. So that's very useful for students like you might have sixth or seventh standard student or 10th or 11th standard. They can also appreciate that. First thing is to tell them what is machine learning, what is data modeling, using examples from daily life. Like, all of them these days, kids, they use at least some form of social media, and then they are surrounded by suggestions. You can say, what if you are on Instagram, what suggestions does Instagram offer you? If you are on Netflix, what suggestions does the system offer you? So have them realize this thing, rather than, I could go into very technical details of ML, but I want to keep okay, Pauline is asking if machine task taught, their academic level be below mostly learners like to machine. Yeah, Shireen is saying, can we introduce sixth, seventh standard student to Python AI? Yeah, that is of course. You can do that. And well, if generally if you're sixth and seventh standard students, I would not like to overburden them with programming languages. So one of the things that we do, one of the mistakes that educators that we do is we overburden them with programming languages. And we try to teach them that to know machine learning or to do machine learning, you have to know Python, you have to know AI, you have to know high level programming, deep programming. That's not the case. I mean, that is um, assumed thing that people have a perception that we have to do that. Um, but these days, there are tools that you can visually train a machine to do something. So there are many such examples. In India, also, I think there are tools like Robo Cleaner. So Robo Cleaner is an application from daily life in which there is a Robo Cleaner, which if I set it on, it is going to itself learn the topology of my house, like stairs, etc., etc., and where are the walls. It is going to automatically make a model in its mind about the topology of my house. And then it will start cleaning itself. It will learn where is the hard floor, where is the carpet, and it's going to start cleaning itself. So it replaces me telling it how to behave where, and it learns on itself. So there are many, Sudarshan is saying, can some machine learning apps that would enable small children to learn basics? Yeah. So definitely we can have a lot of these simple apps that, and there are too many to name. So I would first suggest you guys that, if you are school teachers, first motivate them by telling them what is machine learning, what is data modeling, before you go into more technical details. Now, let's go a little bit more into the slides. For any machine learning data modeling project, you need to understand three things, or you need to have three things clear. What are the three things? Is task. You have to give the machine a very clear task. So the machine is going to ask you, what do you want me to do? Yes, Vani Priya, yeah, it's one of them. Yeah, it's a tool that can write program it without writing code. So Vijay Kumar, what are the data models used in ML? Well, some of the data models we'll talk about is decision tree, maybe. Decision tree is one of them, and then there is neural network and all type of data models which model the learning of the machine. So how does the machine learn? So before we jump there, I wanted to tell you any ML task has to have three components. What are the three components? There should be a well-defined task. So think of it like a robot asking you. The first thing the robot will ask you is, good morning, sir. What do you want me to do? So then you have to give the machine a task that I want you to learn to predict the house price. That's what you tell to the machine. The machine comes to you and you tell that to the machine. Then the second question the machine will ask you is, what experience will you give me? Experience means training data. Like, I can say, I'm going to give you previous 100 house prices and their features, and you learn from there. So, and the third thing is, how will you test the machine? So, three things. Um, Now, if you can put this into a daily life, what, so there is a task. Student comes to you and says, sir, what do you want me to learn? So you tell them, I want you to learn to solve an equation. And then you say, well, the student will ask you, what type of training will you give me? And you say, well, I'll give you some solved examples of solving an equation. Then the student will ask you, the third thing is, how will you measure my performance? And you say, okay, I will measure you based on correct answer or based on technique. And then the machine, which is will start taking over, and it will start doing the task. So three things that you have to define in ML data mining, which is task, experience, error. So the task, as I said, it could be any of these. The performance metric is how is the machine measured. So machine is like a human being, it's like a robot. Think of it like a human being. It is asking you, how will you measure me? How do I improve myself? Okay, and so this is the second thing. The third thing is, what experience do you want to give the machine? So the theoretical definition of machine learning is a computer program. Think of a computer program like a robot, or think of it like um, some self-learning system. It says to it's said to be learned from experience. So you say that it learns from experience with respect to some task T and performance measure P. The next line is very important. If the performance on the task as measured by P improves with experience. So the performance of the machine with more experience should increase. That's the definition of ML. Now, let me answer some more questions. How can we bring machine learning into subjects? Flory is asking, Bessie is asking, can you please mention any two AI app to make student understand machine learning? So yeah, let me answer a couple of questions. Is some of you are asking about specific languages like C++, Java. Ambika A is asking about Java. And so that is one of the mindset that we have, and that used to be a mindset that to be good at data modeling, you need to have a lot of language experience. You need to have Python, Java, C++. But this is a field where even you can visually train things. I've been saying that a couple of times, but you do not need to really have a programming background. This is different from traditional programming. So if I can convey this to you, um, that would be my aim for today. If I can convey this to you, that data modeling ML is not the same thing as traditional programming. If I can convince you this, that would be an hour well spent. So let's move forward. And so data modeling, machine learning is designing algorithms that iteratively learn from data, and designing of methods where the machines use experience to perform or improve performance. Okay, and now do you think there are some challenges of machine learning? So if you can type something, machine learning sounds great, like it sounds that it is the solution to all our problems, but do you think there are certain problems with machine learning? Or do you think it's easy to get the machine to learn? I see some replies, not all the replies, but I see some of them. Yeah, the answer is, there are many things that we cannot really train the machine to do. So it's not such an easy task. If it was as easy as that, then everything would be um, replaced by machines. So it's not an easy task, and some of the problems that we encounter for machine learning is, one of the classic example is not enough training data. That is one of the classic examples, and identifying what is it has to learn is difficult. Good. So not enough training data and identifying features of the data. So now you can to make machine smell perception. Okay. Now all over the world, like I'm in US, you are in India, all over the world, people are trying to develop image recognition application, right? So why do you think um, image recognition applications do not work so well? Well, for the first thing is there are features that are difficult to identify. Like if I tell you, if I want to tell the machine what exactly are the features to look for, it is going to be a challenge. Like, I showed one of the slides, couple of slides back, which is I showed you. Let me go over and show you something that I showed earlier. This is the image. Now, if I want to recognize a face, then, well, I need to first of all identify what features to look for. Some of the classic examples are distance between the eyelids, the distance between the, one end of the mouth to the other, etc., etc. So even if we could fully um, examine the features, that would still be a challenge for us. So one of the challenges that I said is challenge number one, and I'm going to write the challenges in the chat thing. I hope you guys can see. Challenge number one is how to identify the correct features. By that, I mean, if it is a human being, what features should I look for? That is called feature engineering. You might have heard this term by people, which is feature engineering. What is feature engineering? Is identifying the correct features to learn. For example, I was involved in a project, and I hope you guys are able to see my chats. There are public chats. I think it is sent to everybody. And so let me give you an example. We were trying to predict house prices. I was given an application to predict house price, make a data model for house price. Now, normally thinking, what features of the house do you think are important? Somebody could say, well, the size of the house, the number of bedrooms of the house, and um, other such features, other such obvious features. Like, is there a, I'm not able to see the chat. Okay. Uh, okay. Location of the house, etc., etc. But even if you tell the features, yeah, Jyoti is saying the material used in house construction. But even if you use those features, it is still not going to be a very 100% correct model, or even 90% correct. Why? Because we haven't identified the features. So it turns out that, we did feature engineering, the area on which, yeah, Vijay Kumar is saying area, yeah, area is important, and these are obvious features, but there are certain features which are not obvious, and those may be features like, how far is it from a school, how far is it from the main road. So maybe in everywhere all over the world, people don't like living very close to the main road. So those are some of the features that you cannot manually engineer, so you have to uh, let the machine engineer some of the features. So if it was as easy as just finding the attributes and training the machine, that would be a very easy task. But it's not as easy as that, because we cannot fully identify all the features. So these are some of the challenges. And the one of the big challenges is identifying relevant attributes from the data. Sounds obvious, but it is not obvious, because there are some attributes that human beings can identify, but the machines cannot identify. So, just as telling you something about it, there was a Netflix $1 million competition. Some of you might have heard of this prize called Netflix $1 million challenge. And what it was is to build a recommender system that is better than the Facebook or Netflix current recommendation system. So that was $1 million prize, and the people who won the prize, which I can share the link of the paper to you guys. And there was
Hello, sir. We can't hear you, sir. Hello.
I think just give us some time. So the presenter had some technical difficulty. He's joining back, and we will be answering your questions shortly. So just a minute, and he should be joining us now. Yes, the session has started, and it's been happening for the last 30 minutes.
okay. I hope you guys can hear me now.
Yes, sir.
Okay, good. So sorry for that technical glitch, but so feature engineering is a classic thing that data modeling suffers from, because you never know if the features that you have chosen are the correct features. Then another problem, especially these days, is high dimensional data. So I hope all of you are familiar with the term called big data. So big data, which is also part of data modeling, is how do you make traditional algorithms work with very large data sets. So these days, there are data sets which are in billions and trillions of gigabytes. So how do you make a traditional computer work with such a large data set? So you can create a decision tree in the normal, maybe 100 MB file, but how about 100 terabyte file? Can you make your algorithm scale up? Well, that's a challenge. Um, so that is where a field of learning called deep learning comes into play. And we have talked about basic learning, and deep learning is what I wanted to talk about, which is identifying features as well as uh, data modeling from the given training data. So, any more questions? I'll be happy to answer before we proceed to the next topic. Okay, so let's move forward. I wanted to focus on a branch of learning called deep learning. What is deep learning? It is a form of learning that mimics human brain. So let me tell you an example, which is if we could really make a good model, we could make a machine resemble a human brain. Now, do you guys know how data modeling or processing happens in the human brain? Or what is the basic unit of processing, data processing in the human brain? Okay, I hope you guys can see the image, can see the slide. Neuron. Vijay Kumar AV, good answer. Neuron. So um, the and I hope you guys can see the chat. The aim of data modeling or machine learning is to make a machine behave like human brain. And I have typed this in the chat, and I hope you guys can see that. Um, Network of neurons. A lot of you are giving the correct answer. So I hope you guys can see what I typed in the chat, which is aim of data modeling is to make a machine as smart as a human being. So before we do that, um, like you all tell me that we need to have a model, a data model that resembles human brain. Now, how does the human brain work? Okay, so some people are saying the chat is not visible to them. Yeah, I wish it was better, but yeah. So you can just have to take my word for it that basic unit. Okay, can you see now? Okay, Kartika is saying you can see now. So, okay, neuron for human. Takshani is saying neuron for human, perceptron for machine. Exactly. So our aim is to create a model or a data model or a machine learning algorithm such that we can replicate the performance of the brain. So if I ask you, how many, broadly speaking, how many parts are there for sensory human brain? So there is a part called input neuron or input part. What does the, so I hope I'm going to type again in the chat box and hope you guys can somehow see that. So input neurons, hidden neurons, and output neurons. So there are three type of neurons that we work with: input neurons, hidden neurons, and output neurons. The purpose of the neurons is to send signal from one part of the body to the other part of the body. So if I can get the machine to mimic human brain, that would be a big success. Now, the problem with that is in our brain, there are billions of neurons connected to each other. So to replicate human logic, we would have to come up with so many connections in the brain. Now, before we go ahead, let me talk about how one neuron works, how one perceptron works. The way one perceptron works is it gets the input from the environment. So see this? I hope you guys can see my screen. So it gets inputs from the environment and it reacts based on the input. So one of the things that a human brain does, or one neuron does, is it gets sensory signal from the environment. So these are n sensory signals and they each have a weight. Now they are coming into my neuron, one neuron. The neuron has a power to react or not to react. Reacting means the output is 1, not reacting means output is 0. So we define something called thresholding, which is if the signal from the environment is more than some threshold value, then the neuron will reply. Otherwise, it is not going to reply. Now, let me ask you a question is you can touch a surface maybe. If the surface is not more, the temperature is not more than some threshold theta, then your brain will not feel anything. Once the surface, maybe it reaches above 50 degrees or 45 degrees, then you will be able to feel something. So that is called the brain, one unit reacting or not reacting. So this is the first thing that we need to do to make a model of our brain is to design something called a perceptron. Perceptron can choose to react or not to react. The second thing that I'm going to talk about is here. I want to talk about this thing. And I wanted to show you a neural net because we run out of time. So here is a simple neural net. What is this? Is I'm getting signals from the environment and I'm learning to behave based on those signals. And a full-fledged neural network looks like this. Input from the environment, your hidden processing layers, and your reaction layers. So getting input, processing the input, and reacting appropriately. And that is called the designing something called a neural network. So if we could design a neural network, then we would have a very smart machine that almost replicates human brain. So the thing is, if we can get such a architecture to work, we would be really happy. Now, just for those of us who are in the education field, I want to present something which is before we get very mathematical and very technical. I want to present you something called history of machine learning or neural networks. Now, do you all see when the real progress in um, designing? Okay, Venkat Uday is saying, explain in detail about the three layers of neural network. The three broad layers are input layers, and they correspond to our input sensory organs. For example, our hand, our eyes, our nose, for example. And the hidden layers are those that do the processing. They process input signals. And output is whether the output is high or low, whether we feel the pain or not. So, as school teachers, this is something you can present to your students, and they will be really happy to know the history. Is in 1940s, there was a movement to create a machine that resembles human brain. Why do you think it happened in the 40s and 1943? Because that was the time when the World War II was going on. Okay, Sangeeta Vinod is saying, can you show me a simple machine learning program? Yes, we will show you that in the next half, but I want you to tell about there is a tool called TensorFlow Playground. So if you can show this to your students, TensorFlow Playground, which I typed in the chat box. Somehow you guys are not getting the message, but there is a visual tool called TensorFlow playground. And I encourage all of you to take this and show it to your students how a machine learns, rather than bore them or overwhelm them with code. So that's one thing yeah, Radha is sending the link. I hope you guys can see the link. So that is a visual tool that can be used to train a machine. So as instructors, one of the things I want you to realize is, please keep two things separate. One thing is programming, and second thing is data modeling, machine learning. So these are two separate things. uh, do not try to tell your students that you need to have a very high level of programming aptitude or programming skills to be able to do data modeling, machine learning, AI. Okay, so there are various websites that can do that. One of the questions in the chat is, can you show me some websites? So there are tons of tools. One of them I mentioned is a tool developed by Google called TensorFlow Playground. And it's a really nice tool because you can train a machine. Okay, somebody is moving my slides. I don't know who it is, but somebody is moving my slides. Okay, so as I was telling you a little bit about the history, the idea of an electronic brain started in the 1940s. People said, let's make something that resembles human brain. That research led in 1957 to a unit called perceptron. Perceptron is one neuron. You can think of one perceptron as one neuron. Now, that was great. People were very happy with one neuron. And the model of a neuron that I said is, this was the model of my neuron. Very simple model for my neuron. It was this model. Yeah, this is the model of a neuron. That's the progress people made in about 20 years, that we can make a machine just like a human by making this type of a model. Then the year came 1969, when people sent, like an astronaut went to the moon in 1969, but they still could not figure out how to solve a nonlinear problem or to make a machine that behaves much like a human being. And they stopped making any progress in the area of neural networks or machine learning from 1969 all the way up to 1986. They did not make any progress. So in fact, that age is called dark age for AI, dark age AI winter. In 1986, when we made some progress uh, towards making a human brain or making a machine similar to human brain, we developed a technique called perceptron or multi-layered perceptron. And training was using back propagation. 1986, they did that, but still they did not reach much heights. In this era that we are living in, or in this decade, 2010 and 2020, that is when real progress has been made in the area of AI. And now you can have tools that can almost mimic a human brain. And by the end of this decade, I wouldn't be surprised if we have a technique in which you can let the machine run by itself and gather knowledge by itself rather than human intervention. So, um, we are not far from that technique where the machines will start overtaking the manual task, and we will not have to explicitly program the devices. So in this era, and there is something called deep learning. I hope you guys can see. So deep learning is what everything is going towards, deep learning. And you might hear this buzzword, people talking about this buzzword a lot, deep learning. Okay, Jyoti R is asking a very nice question is um, how can we teach ML AI to students? So that should be our primary focus. So how to get students to become familiar with AI ML? One of the techniques I always suggest is ask them how many interactions do they have with the automated learning system in their daily life. So ask them to make a list is what are some of the areas in which they interact with the machine and the machine tells them something. So if I ask you this question is in your daily life, can you tell me an area where the machine helps you with something? And you can ask them this question. So the first you can give them a hint maybe. The first thing is if they use Facebook, then the machine gives them what? Machine helps them with what? There is something called friend suggestions. So when they receive a friend suggestion, it is an example of ML in their daily life. Friend suggestion, because the machine is telling them you might be interested in being friends with this person. The second area in which they interact with ML system, AI system, is Mateshwari is saying good Google Map. So the Google Map um, automatically interprets their location. And yeah, Bhavani is always right, is right. She says face recognition in mobile, Google Assistant. Tons of such examples. So first thing is before you ask them list the areas in which you interact with the machine in your daily life and the machine helps you with something, maybe Uber, if it makes a suggestion, that's fine. But there should be something where the machine learns about you and makes some prediction of the unknown. For example, voice recognition in Google, that's a good example. So YouTube, Sangeeta is saying YouTube. Yeah, YouTube has something called YouTube suggestions, or it's called suggestions. That is another way in which you interact with the machine. And so ask your students this question, where do you interact with the automated system in your daily life? And there can be tons of such examples. Ask them to do that. Then ask them how is the machine helping you? So they would say on YouTube, it is helping me find new videos. So when you watch YouTube for a longer period of time, it will learn your preferences and it is going to give you new things. Srimati V is saying Google suggestions for keyword search, Snapchat recognizing face. All of them are really good examples. So before you go into very fingerprint sensor, not so much because it is just reading your fingerprint and telling you what it is, but something where the machine helps you with certain activity. Facebook suggestions, smartwatch. You're right. So ask your students to do this for you, and then ask them that what input are you giving to the machine and what output is the machine giving me. So input to the machine may be something about you. For example, your face, your watching history, viewing history, or you are giving the machine something about yourself, some data about yourself. And what is the machine giving to me? Maybe some suggestions, maybe something that I need to do, weather forecast, yeah, face lock, another example. Um, Facebook friend suggestion, Anish MN. Yeah, that's exactly right. So ask your students uh, first to do this activity. Identify automated systems in their daily life, make a list of them, and tell us what input do they take from you and what do they learn. Second thing is, do they take explicit input or do they take implicit input? So what is explicit input? Is you have to sit there and tell the machine about your preferences. The second thing which people like more is implicit preferences. The machine learns about you without you sitting there and telling the machine. So when I simply watch the YouTube videos, it learns about me and it makes suggestions. I do not have to tell it, what I like, what I do not like. So it would be like, if you go to a restaurant and the person or the machine learns your preference just by looking at your previous history. Okay. So it's almost time to wrap up. So do you all have any questions? And you all asked very good questions. So do you all have any more questions for me?
So DPS asks like why Python is commonly used in machine learning.
Well, Python, and frankly, the good answer to that is it is a language that was used at Google as their internal language. Now, the newer technologies like deep learning, TensorFlow, they are all based on Python. So Python is a language that has gained a lot of popularity because many tools, the recent tools, are based on Python.
Yes, sir. So and Merin has asked what exactly is the difference between deep learning and machine learning?
Well, as I said, one of the answers to this question is machine learning is you are telling the machine what to look for, right? And deep learning is the machine automatically learns what to look for. For example, I simply watch videos and the machine learns my preferences. If I have to manually sit there and give the features to the machine, that is going to be traditional ML.
Yes, sir. And so we are
Now, some
running out
people
of
will
time.
ask this question is decision tree, etc., etc. Yeah, those are specific type of models, but and the next presenter will talk about that is programming specific type of models. The aim of this talk was to briefly introduce you to the concept of ML, data modeling, AI.
Yes,
Any
sir.
more
So
questions?
yeah, yes, sir. So all of like similar questions only, sir. So
Okay.
thank you, sir. Thank you for spending a valuable time for us, and you have given explained basics of all the machine learning techniques. So thank you very much, sir.
Okay. Thank you. Thank you.
Hello, Mr. Ashutosh. Hello, Mr. Ashutosh. Can you switch on your video? Can you hear me, Mr. Ashutosh? So I can't hear you. If any problem exists, just exit from the room and again enter. So he'll be connecting soon. And most of you have asked the questions regarding session links, and we are getting so many mails and phone calls. The thing is, the first day, whatever link we have given, so the same registration link can be used for all the 5 days. And like Zoom, WebEx, this is Webinar Jam platform also, you are using a mail ID. So using which you are registering. Okay, so kindly see that you are giving your correct mail ID. So if you are giving the correct mail ID in the Webinar Jam platform, using which you are just watching all the sessions. So to those mail IDs, to those attendees, we are sending the feedback link. Okay. So kindly make sure that you are using a right, that is correct mail ID while registering the Webinar Jam platform. Okay. So and you can even use the same day one link. Even you can inform all your friends. So many phone calls we are getting. So just clarify them also. So the same registration link what we have sent in the first day can be used for all the day session. So every day we are having so many queries regarding that. So Mr. Ashutosh,
Yeah, Ms. Dhanlakshmi, are you able to hear
yes,
me?
yes, I can hear you.
Okay,
Can you
perfect.
switch on your camera?
Yeah, just a second.
Yes,
Okay, just let me know if you guys can see my screen right now.
yes, we can see.
Awesome.
So we are very happy to welcome Mr. Ashutosh Senapati, and he has completed his college bachelor's in computer science and engineering in College of Engineering and Technology, Bhubaneswar, and he is now currently doing his master's in computer science at University of Texas at Dallas, and he is also the coding instructor at University of Texas Dallas in computer science department as well. And he has even experience as software development engineer in Accenture, Bangalore, and now he is doing his masters and as well coding instructor. Now I hand over the session to Mr. Ashutosh. So I
Thank you.
don't want to waste the time. Thank you. Thank you.
Yeah, thank you, Ms. Dhanlakshmi. So yeah, thank you for the introduction. So yes, I am currently pursuing my master's in University of Texas at Dallas, and I specialize on machine learning, artificial intelligence, deep learning, and neural nets. So today, what we're going to talk about is, actually the logical progression. Given that since I have been teaching for quite some time now, and I have been tasked, um, to explain how exactly to teach machine learning and AI, especially to the new guys who are coming in into this field, especially to the school children, right? So this is a step-by-step process that I have. I think it will work out. So what I believe is, like, when we're talking about a step-by-step approach, we should first learn like what exactly appeals to the younger generation more. Okay, so I see some messages coming in regarding the recordings. Yes, those logistic details will be handled by Ms. Lakshmi. And if is it possible to draw? Okay, turn whiteboard on. Yeah, this is good. So everyone can see my screen, right? Can I get an affirmation quite quickly?
Yes, we can see, and they'll be posing in chat box. So I
Okay,
can see. You can proceed.
awesome. So machine learning is, I would suggest, like Dr. Nagar was speaking. So I have worked under Dr. Nagar for quite some time now, and I'm currently enrolled in as one of his assistants in UTD itself. So we are currently taking a course together and teaching, new grad student of UTD as well. So this is what we basically talk about. And when we talk about machine learning, especially the new age machine learning, the way I like to call it, has anyone here heard the name of Vladimir Vapnik? I saw Dr. Nagar's slide, and there was a little mention of that name, Vladimir Vapnik, right there. So you guys would remember, like, when he talked about the AI winter, right? So from 70s to 85, actually there was little to no progression at all, and then suddenly Vladimir Vapnik comes in and he just revolutionizes this particular field. And the way he does it, it just gives an endless possibilities to the realm of machine learning. So that is what machine learning So I'll probably just go around, like, talk what machine learning is. Like, I can just go on, and I can just go to artificial intelligence and talk about that. Then I can go about supervised learning, and I have been tasked to explain what decision tree is. But the real motto here, what I want to actually convey here, is what exactly and how exactly, more importantly, to teach, and so that the younger generation who are coming into this field, especially in the school level or in the undergrad level, so they should find it much more, much more, interesting, so that they actually invest their time, and so that they invest their own skill set into this particular field. Because currently what we need is people who are actually coming into this field should be having, number one, a mathematical background. I mean, that is kind of a must in machine learning and AI, because 90% of machine learning and AI field is mathematics. I mean, the equations are just too large, and you have to know Fourier, you have to know Laplace, you have to know Lagrange. So a student who has a mathematical background does have a very high scope in doing well, especially in machine learning field. So if we see a student or someone who is actually mathematically strong, which actually happens to be the case with most of the Indian students, right? So it's here in the United States, like, it's been assumed like Indian students have a very strong mathematical background, and that's quite a good thing. And it won't be a surprise, maybe in the next 10 to 15 years we'll be having most ML papers coming out of India, or let's say most AI researchers coming out of India, right? So it actually becomes highly imperative, especially for us who are currently in this field, just to pass on the baton to the younger generation, and to the students who actually are interested, so that they can actually carry on this research work that's what we have been doing, right? So, okay. So ML over here, as you can see, has few necessary components that you need to understand, right? And I saw someone actually posed a question regarding how exactly can we convey this particular complex message, which is machine learning and AI, to the students who are not necessarily that much, who are not exposed to that much complex mathematics. How exactly do we simplify it and then convey it to them, right? I mean, that could be one of the concerns that we can have. So number one is, just start with the grassroots level. So they need to have a good Python programming skill. So these are the three musts that you got to know. These are the three pillars of machine learning. If you want to become a machine learning researcher, or let's say if you want to, go further in the machine learning field, number one is you have to know Python. Now, I heard a question, why only Python in machine learning field, right? So I heard that question. Someone asked that particular question. I want to answer that particular question first. So the reason why we're choosing Python and not any other language in this context is because Python is much faster. Can anyone tell me why exactly Python is much faster? I mean, this is just my claim, right? But there is a reason to it. Everything has a reason to it. Okay, let me give you a hint. It has to do with how easy Python is, how easily readable Python is. That's the reason why it is very slow as well. So programming language can be high-level programming language as well as low-level programming language, right? When I say low-level programming language, you can call them as machine-level programming language. For example, COBOL. No one uses it really these days, right? But there was a time when people used to use COBOL, maybe 30, 40, or 50 years ago. And the code that they wrote was, quite similar to the assembly language. And assembly language literally has very less variance as compared to the machine code, the actual machine execution code, right? Wherever high-level language, we have something like, let's say, Python, we have Java, which are easily readable by us humans, and they need to be converted into this low-level language so that the machine, the actual computer system, can actually read it, right? Please let me know if anyone has any doubts. I mean, this is really pretty simple stuff that we are talking here. Since Python is a very high level language, we are converting it back into a low level language or a machine level language. And then we are performing the computation, and then we are returning back the results. Since it is a very costly computation and a very costly transaction, that's the reason why Python is very slow. So nonetheless, it is very important to learn Python, because most of the Python libraries in machine learning AI that we'll be using, for example, TensorFlow or my favorite, Keras, they're all in Python, right? These are all extension of Python libraries. And let's say scikit-learn, NumPy, or Pandas, right? So these are very useful Python libraries that you have. And if you know Python, then yeah, just go ahead and use it. But to know it, you got to know Python, number one. Number two is, of course, like I said, the cornerstone of, genesis of machine learning, mathematics. So this has to be strong. Right? And the third thing, not quite intuitive though, the third thing about machine learning is like, what it never changes is its unpredictability. For example, today, if we have a certain model that is working fine, and then in the near future we have a certain data set, and if we feed it to the existing model, let's say, which is 20 years old, that might not work out very well. So third thing that is, it should be scalable, right? So make sure you know Python, you know mathematics, and you have a vision for the future. When you say you have a vision for the future, that is, you are building a model which will accommodate not only one set of data, but different types of data. And it should be accommodative of different kind of computation that might be thrown to it, right? So in order to learn machine learning, you got to perfect these three. Okay. Yeah, like Vijay is saying, large number of lines to just to add for COBOL. Yeah, that was the time. Like, life was really hard those days. And in Python, all that you can just do in one single step. I mean, there was a time 10 years, 20 years back when people used to use Java. I don't know how many of you still use it. Even I used it at a given time. So the thing is, like, in Java, even you have to declare variables, you have to add them up, you have to store them in a variable, you have to return the variable. So that is, the process. In Python, you don't even have to do that. All you have to do is like return a plus b. I mean, in just one single line, and everything happens right there. But with this easiness of writing the code, with this easiness of reading the code, we introduce a certain level of abstraction. And when we introduce a certain level of abstraction, it just takes the language away from the machine level code, or it just becomes more high level, and hence the conversion cost increases. Okay. So what you're going to learn, first of all, is I'm going to show you some basic NumPy library stuff. So I'm pretty much more into technical stuff of machine learning. So I like to implement things. And when I say implement things, I like to do them from the scratch. So I have a couple of models, and if necessary, I can probably share them with you. Like, they're totally open source, except if you like I have some proprietary property as well regarding my projects. So I can share you the open projects that are still finished, and you guys can just go over it and see what advances, like here at UTD we are making at the machine learning level. So one of them will be like, I'm working on a deep learning project, which, let's say, have you guys heard about, let's say, the deep fake videos? You guys have you guys must have seen that particular video. It got quite famous, actually. So there was Obama and there was Donald Trump. So in case of Obama, it was a simple picture of Obama, and in case of Donald Trump, it was Donald Trump who was making the speech. So I can actually map the expressions, I can actually map the lip movements, eye movements, speech, voice from Donald Trump to Obama. So Donald Trump will be saying one certain thing, one certain sentence, and it will seem like Obama is actually saying those exact sentences. So that is what I have been developing. So I have actually developed 90%. It's on my GitHub link. I'll probably share it with you guys, and you can just say it. So that is the level of implementation that is going on right now. Again, with great responsibilities come great challenges, right? So this is nonetheless how I should put it, a great opportunity, but there are challenges that come along with it. So you again have to make sure this particular generation of students who are learning this particular machine learning do not abuse it, or let's say just go ahead and build something drastically evil, which is entirely possible, by the way, right? So we can use deepfake videos to inflict damage on our enemies or something like that, but we should actually refrain from that. So there are many powerful stuff that we can do with it, just make no mistake. Okay, so another cool project that probably you can ask the students to do is something like this. So this is what again I implemented. So I actually got a camera. It can be any normal webcam, it can be any normal VGA camera or something like that, but it should be like post 2010 or post 2005 level camera, not those old camera where we were everything was cloudy and all, like we were not able to distinguish people in the pictures. So get a good camera. So what we did was we probably just put on a camera at the front door of our classroom, and whenever students walked in, it just automatically detected their face and it just automatically marked up their attendance, right? So the manual stuff was gone basically. So even though you were coming inside the class and you are leaving the class before a given stipulated amount of time, your attendance will not be marked, right? So you have to come in, you have to sit in the class for at least 40 minutes, and then basically your attendance will be marked. Yeah, I mean, there were concerns regarding the privacy part of this particular project, but yeah, that was quite fun. So these are the projects which actually open up the minds of the students, right? These are the projects which actually make them enthusiastic to take up machine learning and artificial intelligence, right? Yeah, thanks, Thomas. Thanks for correcting. But yeah, with great responsibility, there is a great risk as well. So for example, you have been loaded with a great responsibility that you have to deliver this particular thing, and you don't deliver it, and somehow it goes wrong. So there's a greater risk as well. But yes, I'm willing to accept that with great power comes great responsibility. Wasn't that Spider-Man? I think Indian Space Research Organization is going to use Bhumitra, a robotic astronaut, for space research. Yeah, like there will be some aspect of deep learning and artificial intelligence application on that stuff. So I'm not saying that it has any sort of limitation. I mean, if there are any limitation, we haven't discovered them yet. I mean, but yes, there are certain technical limitations, of course. Let's say your accuracy might not be better than 98% for a given certain model, right? But nonetheless, it is still working. And it is very viable. It is very possible that I have not arrived at a machine learning model which can actually give me an accuracy of 100%. Okay. Now, having said that, let me just let me just take a quick poll over here. Okay. So I'm just going to ask you guys in the poll, not machine learning proficiency. I'm going to ask you Python proficiency. Okay. And I'm going to say good, average, newbie. And all you can do is just go ahead and participate in that particular poll. Okay. So I have published the poll. Go ahead and just mark in there. So I just want to know how much Python do you guys know? So that's fine. Yeah, like if you're new, that's totally okay. Because what we're going to do here in order for me to, demonstrate the beauty of, let's say in this case, I have just picked up one model, which is decision tree. You guys need to know some basic Python. Or what I can do is probably I can just jump into the NumPy, pandas, and mat.lib libraries, and then I can probably just share you my Python repository where you can go ahead and practice it. And in the meanwhile, I can just explain you the decision trees, how things actually work behind the scene, and not going into what makes them work, like what is the code behind them. So far 46% are new to Python, and 34% are do consider themselves like not good, not bad, but average, and only 20% of them actually consider them to be good enough. Now, good. So this is a great feature that we have over here, right? Okay. Now, in the interest of time, I'll just move ahead and I'll just start with I'll just start from the basic. So machine learning has a word learning in it, right? So again, that learning can be two types: supervised and unsupervised learning. I hope everyone knows what supervised learning is, right? Supervised means I am holding someone's hand and teaching him to learn, right? That is what supervised learning is. Unsupervised learning, well, we'll talk about that later. Let's come to supervised learning first. Okay. Okay, so is there any free certificate course to learn Python? Well, I'm not sure why you are into certifications. So here's the thing. They might end up giving you some credibility because you completed the course, but if you are actually willing to take it up, YouTube is the best resource. Like there is a ton of free resource in there, and probably the paid ones I don't think they can match up to the free resource that YouTube has, right? So the free resource are just unmatchable. Like the quality and quantity is just way too awesome in YouTube. So do not go for any paid resource. I do not recommend that. But yes, if you do want to like embellish your resume with certification, then yes, Udemy has a pretty good one. Coursera has a pretty good one. So you can go for them. Okay, please share something that we can't access from text or magazines. Okay, sure. Go ahead with NumPy and other libraries, sir. Sure, I very much plan to do that. Okay. Now, I'm not going to teach you basic Python right now. What I can do is like I can simply just start with NumPy and just looking at it, and you guys can actually I hope so that understand a little bit of Python, although it doesn't have that much complexity inside it. But I'm going to share my Google Colab. So everyone knows about Google Colab, right? Let me just share my screen. So this is Google Colab screen. So this is nothing but an open source free Python environment, which actually runs on Jupyter Notebook system itself. So it runs on the Jupyter Notebook ecosystem, right? So anyone who is familiar with Jupyter Notebook ecosystem will not have any difficulties whatsoever. Okay, so what you can do in order to open it up, just go to your Google and just type in Google Colab. Yeah, so I just want to make sure. So here's the thing, you guys can just follow me and type in your code alongside me, or you guys can simply just wait, and at the end of the lecture, I'll probably share my Google Colab notebook, this particular thing, with maybe Dhanlakshmi ma'am, and like she can provide it to you later. How does that sound?
Yes, sir. We will just collect all the materials all the 5 days, and we will send it
Awesome.
through mail at the end. Yes.
Yeah, that makes sense. So first things first, in order to make sure that you are using the correct version of NumPy, go ahead and just simply do this. Right. So what you're doing right now is probably you're just going ahead and installing NumPy on this particular environment if you haven't already. Okay. Now, one more thing that I want you guys to do is go ahead and click on this edit button. So let me know if I'm going too fast or going too slow, right? So the reason why I'm doing this is I can give you as much theory as I want. Like I just want you to do some practicals as well. Okay, so now what I'm doing, I'm going to notebook settings and I'm just turning on this particular TPU. What it does is that it just, nothing is viewed in the screen. Is it just for Premalata, or none of you are able to see it? I think everyone is able to see the screen
Actually,
update.
can you zoom the screen? Can you zoom the screen?
Oh, absolutely. How's it now?
Yes. Yes. Now it is visible.
It's visible? Okay.
Yes.
So since in my end it says requirement already satisfied, because I had already installed, in your end it might be taking some time to install the NumPy. Okay. So once we are done with that, the next thing that we are going to do is probably just import my NumPy inside my Google Colab. So how do I do that? Simply just type in import NumPy as NP. So what this does is basically it imports the NumPy library inside this particular Google Colab environment. And next time, whenever I want to use NumPy, I'm just going to use NP. So this is nothing but an alias kind of thing. Okay. So go ahead and execute it. Now it's well, good and done. Now, the reason why we use NumPy, I just want to give a brief background, but I think we're pretty short in time, so I'll just be quick. So the reason why you use NumPy is because in AI and machine learning, we want everything to be in real time, right? And for that we need to store, alter, manipulate what? Data. So that is the basic thing that we need to do. We have to deal with data. Now, to deal with the data, we need a data structure. In Python, we do have something to deal with, a contiguous array of data, which is nothing but list. We have that already in Python. So why are we exactly using NumPy here? So there are a couple of reasons for that. Just a second. My laptop is a little bit out of charge. Just give me a second. Okay. So the reason why we use NumPy is because NumPy is way faster than normal Python lists and helps in real-time computation. And AI and ML, deep learning, and any learning that you understand rely on the in the instantaneous flow of data from my model to my data set, or vice versa. Okay. 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 So Jyoti, you want some example? Don't worry, Jyoti. I'll be more than happy to share not only one, but let's say 2 examples with you by the end of the lecture, right? So how everything works, obviously 1 hour will not be sufficient, just to impart everything that I know, but to just give you a brief idea where things are right now currently. Okay. So in terms of research, or in terms of like if you guys want to teach someone else, so that might be helpful as well. Okay. Okay, yeah. So yeah, this is a great idea from Thomas. I can probably just go ahead and, so Mr. Thomas is saying I can share the Google Colab link. I can do that totally. Just give me a second.
You can just type in the chat box, which is seen on the right side,
That's
so that
right.
it will be sent to everybody.
That's right. I can do that. So let me just copy the link, and it should be available to everyone right now. Just a minute. And this should be good. Okay. So this might take 5 to 10 seconds to update whatever I'm typing. Okay. So I think I just went out.
You can share your screen again. Can you zoom it? Yes.
So everything good on your end. So can I just proceed?
Yes.
Awesome.
Yes. Yes.
So without further ado, so the reason I'm using NumPy is I just explained it is way faster than the normal Python list that we use. Okay. So I'm just going to show you, since it's just a 1 hour lecture, so I'm just going to show you the most important or the most fascinating thing I can do with NumPy is, number 1, I can create any dimension array. So my data will be stored in a data set, right? Or in data structure. It can be an array, it can be a list, it can be a single dimensional array. Sometimes data need to be stored in a 3-dimensional array, which is nothing but a structure of a cube.
Mr. Ashutosh, can you hear me? We can't hear your voice. So let me check if some network issue on his side. So he's joining shortly. I've informed him. Hello, Mr. Ashutosh, can you hear me? Hello, Mr. Ashutosh. Hello, Mr. Ashutosh. I can't hear you still. We can see your screen, but we can't hear you. So kindly excuse participants, so just network issues. So speaker is joining shortly. To participants, just kindly wait for a few more minutes. So due to some network issues, the, the speaker will join shortly. So if you're not getting the feedback link, just mail to the ID which I have sent the registration link earlier. Because you when you register using your ID through Webinar Jam platform, so you must have given the correct mail ID. Okay, so in this Webinar Jam platform, while registering, you have to give the correct mail ID. So to those attendees, mail ID only, we are sending the feedback link. Yes, you're connected now.
So Dhanlakshmi ma'am, should we take some questions in the interim?
Can you do that, ma'am? So I will check on the speaker side and Bala sir. Hello, ma'am.
Yeah, I'm
Yes,
right
ma'am.
here.
I'll take a few
So
questions for the
should
participants.
we take a
Yes, ma'am. So I'll just call a Bala sir and check out.
okay.
I have
So
called Mr. Ashutosh. He is connecting, but we can't hear him. I don't know what problem is that. So we'll check it
no
out, ma'am.
problem. So there are
Okay, ma'am.
questions coming up. Can you show a sample code written in Python? That's precisely what Ashutosh was trying to show you. So my suggestion to the audience is, if you go and Google and say Python editor, there are many online editor and compiler, right? As he was doing on a URL, you can just open it up. You can write a simple code. Then you can have certain libraries. He was talking about NumPy. These are libraries which are used to write a simple Python code. So that is about for people who are from computer science and who have some basic knowledge of computers will understand what I'm trying to say. Now, there was a question about free certification course. Is there to learn? Yes, you have Udemy, Coursera. These are some platforms where you have an opportunity to learn Python and get the certificate, and it is free. If you want to flash this certificate to the outside world and put it in your digital platform, you need to pay some nominal fees for
Okay,
that.
is it audible
Yeah.
now?
Yes, it is audible. I was just taking some questions. VG here, Ashutosh, so I think I'll hand it over to you. So wherever you left, maybe you can pick it up on the coding of Python. They want to see a sample. I think that's where you
Sure,
were. Over to
sure.
you,
So,
Ashutosh.
so that
Yeah.
was a technical glitch. So what I did was I actually changed it back to my Apple AirPods, and now it's apparently working fine. Yeah. So I think that was a network issue. Okay. So where were we? That was quite a distraction.
Can you zoom it, Ashutosh?
Is it fine?
Okay. Uh, we'll take up the questions at the last since we're running out of time. Uh,
Yeah. Sure. Thank you. So I was explaining why NumPy is basically faster than the normal Python list that we have, right? And one of the primary reason is because NumPy utilizes contiguous memory location. So in order to understand that, imagine something like you are storing a number 5. Let's say you have an array. Everyone is aware what an array is, right? If not, again, I would highly encourage you guys to go ahead and just brush up your basics a little bit. So let's say it is nothing but a list of numbers that you already have, right? So normal Python list, what they do is that they store these numbers in discontinuous manner inside my memory, inside my computer memory. While NumPy, what it does is that it stores these numbers one by one, side by side in my computer memory. So what happens is that it becomes easier and faster, to just go ahead and access these elements if they are stored nearby, as compared to if they are stored, in a more haphazard manner, which exactly what list does. So NumPy is better in that way. So number one is it is faster, and it is much more easier and malleable and much more flexible when it comes to dealing with data sets. So let me just go ahead and show you the some of the magic that NumPy can do. Let me just go ahead and create. So I'll just write in the code and then I'll explain like what exactly I'm doing. So if I just do this, and if I'm just printing A, what I essentially did is I just created my one-dimensional array over here, one-dimensional NumPy array, 1 to 3, right? So, and when I'm printing that particular thing, I'm seeing 1 to 3 is already being stored, right? Now, if I want to see what type this A variable is, can anyone guess what kind of variable A is? It's going to be a NumPy array, right? So this is what you can do. Again, in NumPy, like I said, you can create an array of any dimension, right? So let me just show you how I can do that. So let's go ahead and create a NumPy array of, let's say, 2 dimensions this time. So in order to do that, what I need to do is I need to create 2 unidimensional arrays and club them into one single array. So this is what I did. These are 2 unidimensional arrays and they're clubbed basically inside one single dimensional array. So let me just go ahead and do that. Right. And now if I'm just running and printing my variable B, I can see it is now stored in sort of a matrix structure. Okay, hope that makes sense. So what I'm doing is basically I'm basically storing my array in such a way that it looks like a matrix. And like I mentioned, I can go ahead and make this a three-dimensional array as well. So let's say I'm creating C here, and all I'm doing is np.array, and this time a three-dimensional array will be composed of multi-layer two-dimensional arrays, and in turn the two-dimensional arrays will be composed of single-dimensional arrays, right? So let's just start from the root level. So this is my three-dimensional array. Let's say it will be composed of, let's say, multiple two-dimensional arrays, and in turn those two-dimensional arrays will be composed of multiple one-dimensional arrays. It's just a game of patterns, you see. So if I just go ahead and just give in the data inside that, let me just go ahead and fill it up. You can see now if I just go ahead and print my C over here, let me just zoom it a little bit. You can see data is stored, and it is stored in a three-dimensional way. So A, B, and C are nothing but my NumPy arrays, while the dimension of A is 1 dimension, dimension of B is 2 dimension, while the dimension of 3 is 3 dimension, right? Now, how do I check that? How do I verify that? So one way is like just to use this particular method called a.endim, and it's going to give you 1. If I do b.endim, it's going to give me 2. And if I use c.endim, it's going to give me, well, 3. So these are nothing but my dimensions that I already have, right? And one more important thing, the power of NumPy is, as compared to list, of course. When I'm saying NumPy is powerful, you can always assume that I'm talking about list as a comparison, is that you can actually change how much data each of these integer actually occupy in the memory level. So by default, let me just show you. So this was my A, if you guys still remember. Oh, I'm sorry, this was a small a. So my A initially contained 1, 2, 3, right? If I do A dot D type, it will tell me that each number inside my A is of integer type. That is, it's a number essentially. And each of them is occupying 64 bits. Now, some of you might get confused here a little bit, like what exactly is this 64 bits? Well, it is the space that it is occupying. Just understand this as of now. In NumPy, I have the authority to go ahead and, so this was my A. Where was my A declared? So here, I can determine how much value or how much space does each integer over here occupy. So I can just go ahead and change that. Let me just go ahead and change that to, let's say, integer. And I want each of them to occupy, let's say, 16 bits, not 64 bits. That works. And now, when I do a.d type, it says int 16, which means every integer over a here is an integer type, but this time it just occupies 16 bits. So you see how flexible numpys are? In list, you just you simply cannot do that. Right. So that is why people started learning, started migrating towards NumPy and started leaving out list. So these are just not the only thing that you can do with NumPy. There are multiple things that you can do. For instance, let's say, by the way, one more thing. If I want to, so here, where was my B matrix? So this was my B matrix, right? So it is a two. Okay, what exactly is its shape? Can anyone tell me? Is it 3x2 or 2x3? It is clearly a 2x3 matrix, right? Since it has 2 rows and 3 columns. So you can determine that by something like b dot shape. So it's going to give you the shape of the matrix, which is 2x3. If you want to see what a shape was, you just do a dot shape, and it's going to give you the shape of the a. So it is nothing but, and if I want to do c dot shape, it's going to give you the c shape, which is 2x2x3.
Hello, Mr. Ashutosh. Hello. We can't hear you again.
I think, ma'am, again we have a connection problem, looks like, isn't it?
Okay.
Okay, I think you're back now, Asutosh. We
So I
lost
think,
you for quite some time. Yeah.
yes, I think because of this Google Colab that I'm sharing, like whenever I'm scrolling down, it's just breaking the system apparently, like for this particular application. That's strange.
Okay, thank you.
Yeah. Okay. So where were we exactly? So the reason why I showed you this is because I wanted to know why exactly, how much elements exactly C contains. So you can just simply look at it and say, hey, it's 3 into 2 into 2, right? And that apparently happens to be 12. And if you just scroll above here in your C matrix, you can see like there are exactly 12 elements there. So 3 into 4, that is 12. Okay, so that is one way in order to determine the shape of the C matrix. It basically tells you it's of the dimension. Let me just write it down for you. So 2 cross 2 cross 3, that is 12, right? So this is the dimension of, or you can say the shape of C. But the dimension is nonetheless 3. It's a 3-dimension matrix, right? So you just do this and you're going to get that, right? Now, moving on. Okay, so what else? What else can we learn? So there are a lot many things that you can do with it. For example, you can make use of linear algebra using NumPy itself. I'll just give you an example. For instance, like, but before that, let me just show you this. Okay. For example, if I have a certain variable which can store, by the way, in Python, when I'm declaring a variable, so this is a good reminder. I can actually store a number. That's totally fine. And in a variable, I can go ahead and store probably just a character. That's totally fine. And in my variable, I can just go ahead and store, let's say, a string. That's again totally fine. And in my variable, if I'm just going ahead and storing a NumPy array, that's totally fine as well, right? And at the end, I can go ahead and store any dimension of array inside my variable. So that's completely fine. NumPy actually, let's say if I want to create a 2D array, let's say of dimension, give me some dimension, let's say 2 cross 2. I want to create a 2 cross 2 matrix, which is all filled up with 1. So I have something called np.full. What it does is basically it creates your an array of any dimension that you have, and uh, you can just, let's say, I'll just show it to you. So if I say 2 cross 2, so it'll probably just create me a array of this particular dimension 2 cross 2 and fill everything up with the number that I wanted to. Let's say I want a dimension full of tens. I want an array full of 20s or something like that, right? So I can just use that to deliver. So let me just go ahead and set 10, and if I just execute it right now, and I just print, let's say, A, next I print B, and next I go ahead and print C, next I go ahead and print E or D, print E, and you guys can see this is A, B, C, this was D, and this was E. So you can see what E represented was this, np.full 2, 2, 10. So what this means, I created a matrix of this dimension, essentially 2, 2, right? 2 rows and 2 columns. And the data that I'm filling it in is basically 10. So I just created a full matrix of 10, basically. Okay, so I hope everyone is aware what a determinant is, right? So yeah, that is something that I expect everyone to understand what determinant is. If not, you guys can again go back and just visit those particular concepts back. So based on those lines, I'm going to show you some linear algebra which is possible using NumPy as well. Another thing that NumPy can do is it can actually create random variables as well. So if I'm going ahead and doing np.random dot, let's say, randint, and I just fill in something, and this is the one thing that I'm trying to print, it should print me any random variable between 1 and 10. So if I execute it again, the number again will be different. If I go ahead and execute it again, the number that it will be giving me is again random, and it will be entirely different, right? But let's say Okay, what if I want a matrix of random variables this time? Okay, so what do I do now in order to get a matrix of random variables? Okay, I'll use this particular thing and see how scalable NumPy is. So I'll just do np dot random dot rand int, and inside it, I'm just going to provide the dimension of my random variable matrix. It could be anything, doesn't matter. And then after that, I can just probably give the range until this point. Like I don't want my random variables to exceed this particular thing, right? So I can give that as well. So let me just go ahead and do that. Or I think it's the other way around. Let's say I'm giving 9 and okay, I think I probably have to use this particular thing. I'm not sure about the syntax. Just give me a second. Hope this works. It does. So basically this particular command over here, what it does, same thing as above, except that it will only create random variables, random numbers until 9. And it will create random variables in form of a matrix. And that particular matrix will be of dimension 2, 2. You see how much flexibility NumPy gives you? So that is, again, one of the main reasons to learn NumPy. And if you're learning machine learning, then you're definitely going to deal with lots and lots of data, right? And like someone said, I can probably use NumPy and Pandas just to showcase, in this case, let's say a linear regression, for instance, how basically we're using this particular stuff back in there. So I think we'll be having like enough time just to showcase that. So can anyone please tell me how much time exactly do I have so that I can just compact things up and see what I can show and cannot show?
So already we have reached 10:30, right? So you can go ahead for 5 more minutes,
Okay, awesome.
5 to 10 minutes.
Okay, so what I'll do is like I'll probably just skip this Python technical part, and I'll just go ahead and showcase like where exactly this can be implemented, right? So let me just show you that. Let me know when you can see my other screen. Just a moment. Okay, share the screen and Chrome tab. Okay, I hope it's visible now. So this is one certain program that I had written for you guys, and I wanted to showcase it today. So in order to use that, so we'll be using multiple. So this is how an actual ML program looks like, right? So this is what you'll be doing. So let me just go ahead and correct it. So in here, I'll be using multiple Python libraries. Let's say matplotlib. I'll be using
Can you
pandas.
throw? Can you throw it?
Oh, okay. Is it visible now?
Yes.
So okay, awesome. So this is the place where I'm basically importing what I'll be using. That is all my Python libraries. The reason why you are seeing an error over here is because probably I haven't imported NumPy. So I'll just go ahead and import that as well, right? And the data set in here, so Google Colab actually provides you a way to import the data set as well. So let's say I have it on my desktop and I want to import it over this particular playground. How do I do that? So you have something called upload option over here. And if you just give me some time, I'll just go ahead and upload that as well. So currently it's in my GitHub, and let me just upload my CSV file. So in 3 seconds, you can probably just see that. There, you can see like I have just uploaded my data set in here, right? So my data set will be, let's say it has 1,000 entries. So 750 of them will be used, let's say, as training data. And let's say the rest 250 will be used as the testing data, right? Those 750 could be from the bottom 750 or could be from the above 750. That is, again, up to the discretion of the user. What exactly does he want to consider as the testing data? We can determine, though, like which part will be how, like if my model will perform better if I take the bottom 750 as the testing data or the above 750 as the testing data. So the reason why I say this, because there is a concept called cross-validation. So you guys can just go ahead and Google up, say, cross validation, what exactly it means, right? And then you'll understand what I'm trying to say. So let's say in this case, let me just execute this particular line. Okay, so it's fine. I have imported all the libraries, and now in here, essentially what I'm doing is, okay, so let me just copy its path and feed over here. So this is the path that I gave to my, uh, I'm using pandas over here to read this particular CSV file that I just imported. So this is how I read it. If I just execute it, all well and good, and there is absolutely no error. So the data set that I have, I'll just explain in just 1 minute what exactly it stands for. So basically, I have a data set of companies essentially, and so a company will be making some profit at the end of the day, right? And that profit will basically be dependent on, let's say, some variables like R&D spending, administration, market spending, state, which it is located in, and stuff like that, right? Pretty much in real world, this is exactly what actually goes in order to determine the profit. So let's say there's a company A which spends something like 16,000 or 1,65,349 in R&D, and this much amount in administration, and this much amount in marketing spending, and it is situated in New York. So given all this said, it has been found. So this is the keyword, it has been found that the profit that it makes is something around 1,92,261, right? Similarly, I have many data, maybe 1,000 such data like that. Okay, so this is exactly what I call as my data set, and this is how I import it. Right now, in my data set, there will be something called an independent and dependent variable. Like I do want to go into depth. So understand right now, like when I say independent variables, when I say y equals to x plus 2. So based on the values of x, my y will vary. So x will be an independent variable while y will be a dependent variable in here, right? So so that is exactly what I have defined here, x and y. So set of x and y to be more precise. And now I just go ahead and execute that. And companies.head, what it basically does is it essentially provides you the data from the starting of the table. So this is the start of the table, and it's just a nicer way that Panda provides to represent your data. So this is pretty interesting. This is called a correlation matrix. So I'll just explain this particular thing, and I have actually commented out the entire code. So what you can do is that probably just a few more lines of code now. So this is, guys, this is logistic regression. This is linear regression that we are actually going through. Okay, not logistic regression, my bad. So this correlation matrix, what it tells you essentially is what is the correlation of R&D, let's say, and profit. See, the more lighter it is, the more correlated they are. So or you can assume it to be proportional. The more you spend on R&D, the more profit you get, something like that, right? And you can see the correlation between R&D and R&D itself is the max. The correlation of administration and administration is the max, because there will be extremely high correlation between the same attributes. Make sense? Okay. And the more darker it is, the less correlated they are. Let's say administration, how much a company spends on administration has nothing to do with how much it spends in marketing spending. So they're just entirely unrelated sets of data, right? But your profit here is basically, you can see over this particular graph, this particular last column that you can see. So which is the lightest one? This is the lightest one. That means your profit maximum dependence of profit is on R&D. So profit is like just heavily dependent on how much you are spending on R&D, and least dependent on how much you are spending on administration, because that is the darkest one. So these are the kind of correlation that I'm able to obtain from a correlation matrix, and all this is done with the help of this particular matplotlib or seaborn. So seaborn is nothing but a layer over matplotlib. So using that, what I have done basically is, like, I've done the linear regression. You guys have to understand linear regression for that. So in essence, so this is my training going on now. And after my training, what I did is probably I just calculated the accuracy of the score. So this is, again, I just predicted my accuracy, and I found out that it is 91% correct in predicting the data. So in this case, As I told you earlier, if I had 1,000 companies, I had tested, let's say, 750 of them, right? Or if I had 10,000 companies, then 7,500 had been taken as training data, and the rest 2,500 were taken as the testing data. And out of those 2,500, the last 2,500, my linear regression was able to predict the correct output only in 91% times. The rest 9% times it was unable to predict, the correct output. But hey, that's pretty good. 91% accuracy is, tolerable. I make it tolerated. So this is how you arrive at. So these are nothing but machine learning models. The other thing that I wanted to talk about was decision tree, but because of lack of time, I don't think like I'll be able to cover it. But yeah, feel free to like just contact me, and I'll probably just happily teach you guys anytime you want. So I'll share this particular collab link as well. Just a second. And I'll probably just share all my resources with you guys, and hopefully I'll be able to share my GitHub repo as well. I'm gonna see like if that will land me in any sort of trouble or not, because those are still live projects, and at least the closed ones or the completed ones I'll be able to share. So those are based on, again, neural nets, and those are based on like reinforcement learning, deep learning, and you guys can just go over my GitHub profile. I'll just ping my GitHub profile address over here. So just a second. By the way, this is the recent collabs link. You guys can go over that. And this happens to be my GitHub profiles link. Just a second.
Yes, Mr. Ashutosh, you can just document it and send to me through mail. So
Absolutely.
you just open a Google Drive and put all the 5 days materials and we'll share them along with the e-certificate.
Yeah, that sounds plausible.
Yes. So thank you, Mr. Ashutosh, for
Yeah.
spending your valuable time. And you have given us a good starting point to move further to explore about implementing
Absolutely.
AI concepts using Python coding. So it's
Right.
in our part to explore it. So you have given a platform. Thank you. Thank you, Mr. Ashutosh.
No problem.
Anything
Thank
to
you.
share from your side?
From my side or the audience's side?
No, from your side, I'm saying to audience.
Yeah, I would say like since most of the audience here are like very good teachers from CBSE schools, I suppose. What they can do is probably just go through the basic Python stuff once and go through the basic ML once. So there is a professor called Andrew Ng, whom I very much admire. So go to YouTube and go to his lectures, and you can see like all of them are free, and those are the best you can get in today's world. Like Andrew, nothing tops that, right? Or you can probably
Yes, most of the
go to
participants have asked for the like study materials link which we can refer. You can
right.
even post
So
that in your document.
I'll document it, and I'll probably just send it over. And Dr. Patrick from MIT. So he is again one more. I think he is no more. Like he just passed away, I think, a couple of years ago. But the lectures are still out there in YouTube. You just search Dr. Patrick from MIT machine learning course, and you'll see all the resources right there. And those are quite best. Like those are the top-notch resources that you can probably get. And yeah, I suppose like you guys can just go ahead and utilize that. And after you guys become, let's say, pro in that particular area, you can just reinforce that to your students and just pass it on. Yeah, so that was all from my side.
Yes, thank you, Mr. Ashutosh.
Yeah, thank you.
And all the participants kindly register through using the first day link what we have sent. And today you'll be receiving a feedback link for today's session. And tomorrow, day 5, we are going to have the session on artificial intelligence ethics. And we are going to wrap up all the 5 days recap of the workshop, and which is going to be handled by Ms. Vaijayanti from IBM. So you all attended her session on day 2. Again, ma'am is going to handle tomorrow on AI ethics. So do attend tomorrow's session, and you'll be receiving the feedback link again and the registration link which I have sent already on day 1. The same link you can use, and every time, every day, along with the feedback, I am sending the registration link also. So you can use the same link to attend the session. Thank you.